Welcome to our comprehensive guide on nature-based solutions, or NBS, for urban environments. In this video, we'll explore how cities can harness the power of nature to address challenges like heat, pollution, and biodiversity loss. The NBS catalog organizes solutions in 8 main categories, each tailored to different urban needs. From greening interventions to innovative vertical gardens, these approaches blend natural inspiration with technical expertise. Throughout this series, we'll break down each category, discuss their benefits and limitations, and provide practical insights for implementation. Let's begin by understanding the structure and purpose of the NBS catalog. NBS catalog is designed to help planners and decision-makers select the most suitable nature-based solutions for their specific urban context. Each category starts with a general description, followed by the main functions and how the solution is inspired by nature. For example, when discussing green roofs, the catalog explains both the natural soil structure and the technical aspects of roof design. Solutions are further divided into subtypes, making it easy to compare options. Performance ratings and practical considerations such as costs and maintenance are also included to support informed choices. Each nature-based solution in the catalog is presented in a structured table format. This includes basic information, a general description, the role of nature, technical and design parameters, conditions for implementation, benefits and limitations, and performance metrics. The performance of each solution is evaluated based on ecological services like cooling, water regulation, purification, biodiversity, and amenity value. This systematic approach ensures that users can easily compare different solutions and understand their potential impacts in various urban settings. Performance ratings in the NBS catalog are based on generalized conditions, as it's not feasible to evaluate every solution for every city. The ratings indicate how well a solution performs in suitable conditions, with scores for cooling, water regulation, purification, biodiversity, and more. This helps users quickly identify which solutions are likely to deliver the desired ecological services in their context. Additional criteria, such as costs and maintenance, are also considered to support practical decision-making. Catalog identifies 8 main categories of nature-based solutions: greening interventions, public green space, vertical greening, green roofs, water-sensitive urban design measures, river restoration, bioengineering measures, and other NBS. Each category encompasses a range of solutions, from street trees and residential parks to advanced living walls and biofilters. By organizing solutions this way, the catalog makes it easier to navigate the diverse options available for urban greening and ecosystem enhancement. Start with greening interventions, which focus on the use of trees to enhance urban ecosystems. Trees provide habitats for wildlife, regulate air temperature, control pollution, offer shade, absorb CO2, and create spaces for human recreation. The catalog highlights the importance of both conserving existing trees and establishing new ones. Larger, older trees are especially valuable for their greater environmental benefit. Effective conservation measures, such as tree protection statutes, are crucial for maintaining healthy urban forests. Urban trees offer a wide range of direct and indirect benefits. They improve the microclimate, enhance air quality, and contribute to the overall quality of life in cities. Trees also help regulate rainwater, provide habitats for various species, and create aesthetically pleasing environments. However, the positive effects of single trees are often limited to their immediate surroundings, which is why group plantings and conservation of mature trees are emphasized in urban planning. While trees are often seen as the ultimate nature solution, it's important to recognize potential ecological disservices. Large-scale tree planting can affect street ventilation, leading to higher concentrations of pollutants. Some species emit biogenic volatile organic compounds, BVOCs, which combined with other factors can contribute to ozone formation. Additionally, certain trees have a high allergenic potential. Careful species selection and consideration of local conditions are essential to maximize benefits and minimize drawbacks. Despite these challenges, the potential of urban trees remains promising. Many disservices are linked to traffic-related pollution, which may decrease with the electrification of transport. Stopping or slowing tree planting is not an option, but careful planning and updated scientific knowledge are key. By selecting suitable species and considering new evidence, cities can ensure that tree planting schemes deliver lasting benefits for generations to come. Single-line trees are a common way to introduce greenery along streets, bicycle paths, and sidewalks. These trees are arranged on one side and provide multiple benefits, such as shading, air cooling, and particulate matter absorption. The effectiveness of street trees depends on factors like tree size, canopy coverage, planting density, species, and overall health. Proper planning ensures that these trees contribute positively to the urban microclimate and enhance the well-being of city dwellers. Single-line trees mimic the natural arrangement of trees at the edge of forests, providing shade and cooling to adjacent areas. The shaded surfaces remain cooler than those exposed to direct sunlight. Other benefits include reduced wind velocity, improved air purification, and enhanced transpiration. The specific effects depend on tree characteristics such as canopy density and seasonal changes, making thoughtful species selection essential for optimal results. In planting single-line street trees, it's crucial to select species that match local geobotanical conditions. Adequate root space, irrigation facilities, and protection measures like poles or wire mesh are important for tree health and safety. The distance between trees should consider both the mature size and design goals. Ensuring proper soil quality and stability helps prevent accidents and supports long-term growth. Local circumstances, such as topography, root characteristics, and underground utilities, must be considered when establishing new street trees. Sufficient space is needed for healthy growth, and species selection should account for future height and stability. Proper rooting is essential to avoid hazards, and sometimes soil replacement is necessary. By addressing these factors, cities can create safer, more resilient green corridors. Street trees offer microclimate regulation, habitat provision, aesthetics, and rainwater management. However, it can take decades for new trees to deliver the full range of services provided by mature specimens. Limitations include allergenic pollen and BVOC emissions, which can contribute to summer ozone formation. Protecting existing trees is therefore vital for maximizing urban ecosystem benefits. Boulevards are another effective way to introduce greenery into cities. Trees are arranged along both sides of streets, often forming a closed canopy that shades the roadway and lowers air temperature. Boulevards not only mitigate heat stress but also enhance aesthetics and provide habitats. Their design is inspired by natural forest edges, where trees protect and cool adjacent areas. Boulevards simulate the fringe areas of forests, where trees provide shade and cooling to open spaces like fields or meadows. The effectiveness of boulevards depends on tree density, canopy coverage, and seasonal factors. In addition to cooling, they reduce wind velocity and improve air quality, making them a valuable asset for urban environments. Selecting tree species for boulevards requires attention to durability, resistance to stress, and design principles. Adequate root space, soil preparation, and irrigation are essential for healthy growth. The spacing between trees should reflect road width and mature tree size. Protection measures may be needed to safeguard young trees from damage. In planning boulevards, it's important to consider local topography, root characteristics, and underground infrastructure. Sufficient space must be provided for trees to reach maturity without causing future conflicts. Soil quality and rooting depth are critical for stability and safety. By addressing these factors, boulevards can become long-lasting green corridors in urban landscapes. Boulevards offer microclimate regulation, habitat provision, recreation, and rainwater management. However, they can also reduce airflow, potentially increasing pollution in street canyons. Allergenic pollen and BVOC emissions are additional concerns. Despite these limitations, boulevards remain a valuable tool for urban greening when designed and managed thoughtfully. Groups of trees or arboreta mimic small forest patches within urban settings. They create shaded environments that help mitigate heat stress and provide unique microclimates. Arboreta can be used to design shaded squares, courtyards, or as contrasting elements in densely built areas. Planting mature trees in dense grids ensures immediate benefits, while irrigation supports their establishment. Arboretum functions like a small forest, providing shade and cooling during hot summer days. The dense planting of various species enhances biodiversity and creates robust living conditions. These green spaces serve as important meeting places and public areas for heat reduction, contributing to the overall resilience of urban environments. Create effective arboreta. Mature trees from nurseries are planted in dense grids and irrigated as needed. Using a variety of species increases resilience and biodiversity. Arboreta can be established on natural soils or even atop underground buildings, provided there is sufficient soil depth. These green spaces offer flexibility in urban design and contribute significantly to ecological connectivity. Arboreta provides significant benefits including enhanced biodiversity, improved aesthetics, and public spaces for social interaction and heat reduction. However, limitations include the allergenic potential of certain species and BVOC emissions. Careful species selection and ongoing maintenance are essential to maximize the positive impacts of these urban forests. Public green spaces are vital components of urban green infrastructure. They are categorized by size, catchment area, services, and design aspects. These spaces, often connected by tree-lined streets, form the backbone of urban green networks. The catalog focuses on two main types: residential parks and green corridors, both of which offer unique benefits when thoughtfully designed and located. Residential parks serve as the nearest entry point for nature-based recreation in urban areas. Larger parks may include sports fields and multifunctional spaces, while smaller ones often function as playgrounds or green strips. These parks act as urban oases, improving climate recreation and biodiversity in surrounding neighborhoods. Their design typically features a high proportion of trees and minimal sealed surfaces. Effective residential parks are well connected and accessible for pedestrians. They should cover at least 1.5 hectares and feature a compact layout with over 50% tree cover. The classic London park design, with tree and shrub plantings along the edges and a central open area, serves as a model. These parks can be integrated into new developments or urban regeneration projects to maximize their impact. New urban developments offer opportunities to strategically locate residential parks for maximum climate benefits. Even in existing urban areas, establishing new parks can greatly enhance local environments. Ensuring equal distribution of parks across the city helps maximize their positive effects on urban climate and accessibility for all residents. Residential parks are multifunctional, delivering all the benefits of green infrastructure, from climate regulation to recreation and biodiversity. However, accessibility is a key factor for their success. Parks must be easy to reach and well integrated into the urban fabric to ensure they serve the community effectively. Green corridors are linear parks often created from derelict infrastructure such as old railway lines or waterways. These corridors play a crucial role in urban green networks, connecting different parts of the city and supporting biodiversity. They can also be designed as new elements in urban developments, enhancing connectivity and ecological value. Green corridors function as ecotones or transition zones between different biomes. These areas are often rich in biodiversity because they connect multiple habitats. By transforming old infrastructure into green corridors, cities can create interconnected systems that support wildlife and enhance urban resilience. Green corridors are based on existing infrastructure. Their location and network properties are largely fixed. For new developments, corridors can be purposefully designed to connect key areas. Abandoned infrastructure offers a convenient starting point, as natural features often develop automatically over time. Maintenance needs may vary depending on previous land use. Green corridors are vital for ecological connectivity and the reuse of old infrastructure. They open up new possibilities for creating interconnected green systems in cities. However, depending on their previous use, some corridors may require significant maintenance, especially if they include bridges or other structures. Vertical greening refers to any vegetation cover on vertical surfaces, regardless of where the roots are located. This includes green facades, freestanding living walls, moss walls, and living plant constructions. Vertical greening can be applied both indoors and outdoors, but the catalog focuses on outdoor solutions that enhance urban environments. Sod-bound greening involves planting vegetation directly on building facades, often using panels or containers attached to the structure. These systems typically require advanced irrigation and lightweight substrates. Facade-bound greening can significantly reduce building temperatures, improve air quality, and provide habitats for birds and bats. Technical design of facade-bound greening depends on the building type and structural requirements. New constructions can integrate vegetation panels, while existing buildings may need scaffolding. A variety of plant species are used, and irrigation systems are essential. Maintenance by professional gardeners ensures the long-term success of these green facades. Sod-bound greenings reduce air pollution, lower building temperatures, and provide habitats for urban wildlife. They also enhance aesthetics and can serve as natural noise barriers. However, these systems are highly dependent on irrigation and may be vulnerable to frost. Careful planning and regular maintenance are necessary to ensure their effectiveness. Ground-based green facades use climbing plants that grow from the ground and cover building walls. These systems can use self-climbing species or require supporting frames. Ground-based greening is inspired by natural forest environments where climbers grow on trees and rocks. These facades offer significant cooling and air purification benefits. Ground-based green facades require careful selection of climber species and supporting structures. The facade must be strong enough for self-climbers, or a frame may be needed. These systems can take 5-20 years to fully cover a building, but once established, they provide substantial environmental benefits. Good soil quality and adequate sunlight are essential for healthy growth. Ground-based green facades help regulate surface water, purify air, and reduce building temperatures. They are highly effective at evapotranspiration and can absorb a significant portion of annual rainfall. However, these systems depend on the natural water cycle and may suffer from drought stress. It can also take several years for the facade to be fully covered. Green noise barriers are walls along roads that are covered with climbing plants. These barriers absorb fine dust, reduce noise, and improve the visual appearance of infrastructure. Supporting facilities like wires and trellises are needed for plant growth, and sufficient root space is essential for healthy vegetation. Vegetated noise barriers not only reduce noise but also absorb heat and fine dust, depending on the coverage. These barriers enhance the urban landscape and contribute to ecosystem services. However, their success depends on proper design, maintenance, and suitable growing conditions for the plants. Freestanding living walls are vertical green structures that can be placed in urban environments to increase vegetated surfaces. These walls help adapt to the urban heat island effect, provide high amenity value, and support biodiversity. They are constructed with metal cages filled with soil and can support a wide variety of plants. Living walls are built with vertical layers of soil or substrate, supported by metal cages and fabric to prevent erosion. These structures can reach up to 4 meters in height and require a stable foundation. Irrigation and fertilizer management are important for plant health, and the design allows for flexibility in plant selection. Living walls provide direct and indirect shelter from the sun, reduce heat island effects, and support selected species. They also help with noise reduction and can use surface water for irrigation. However, they require constant irrigation and a strong supporting foundation. In some cases, living walls may act as barriers to pedestrian movement. Noise barriers constructed as freestanding living walls use baskets or elements filled with soil to reduce noise emissions along busy roads. These barriers offer multiple benefits, including improved aesthetics, noise reduction, and the potential for stormwater reuse. Their success depends on suitable underground conditions and natural precipitation.